Another periodic trend that we see in the periodic table is with atomic radius. If we come over here to the right hand side, so atomic radius is not something that can be measured exactly because atoms are so incredibly small. So the size of their orbitals, which is the electrons going around the nucleus, right? But their size of their orbitals can't be measured exactly. I'm trying to talk faster than I can. Sorry about that. So because of that, the atomic radius is not known exactly. But what we our scientists can do is estimate that value by measuring the distance between two nuclei when nuclei when two chemicals are bonded together. So when there's a chemical bond, they can measure the distance between the nucleus of one and the nucleus of the other. And then they can take that number, divide it by two to get the atomic radius. Um, right? So if you have one here and there's the nucleus, we'll make it an X. And you have another atom here and there's the nucleus, right? They can measure this chemical bond distance. And then if they divide it in half, that gives them, like you can see here, the radius of each of the atoms from the nucleus to the outer edge. So that's how that is done, since they can't measure this small of a distance. So the trend for atomic radius, as you can see here in this lovely little picture, the trend is that the radius decreases from left to right, which you can see right here. As you go from left to right, sodium, magnesium, aluminum, you can see they get smaller and smaller. The reason that is as their atomic number increases, there are more protons in the nucleus. Remember, as we have said, this is all the positive and negative game, the pluses and minuses attracting each other. Um, so those more protons in the nucleus, and they pull on the electrons, which pulls them closer together. So it causes that atomic radius to shrink. So more protons in the nucleus as you go here. So sodium has 11 protons, magnesium has 12. That extra proton is going to pull tighter in those electrons, making the radius smaller. As we go down, however, down a group, like here's the alkali metals, right? Lithium, sodium, potassium, rubidium. And you see as you go down, they get larger. Excuse me. They increase down this group because there are more energy levels. So it increases because basically you're adding an extra layer, right? So lithium has the 2 energy levels, sodium has 3. So you basically added another circle, added another layer, causes it to be bigger, right? So that is why they are bigger. Is there's extra energy levels. And then, like it says here, more orbitals and electrons that are further away are held, that should say more, more lightly, allowing the orbitals to be larger and the atomic radius to be larger. So the further away, the less of a hold there is, right? Less of a hold there is, the bigger the radius is. Okay. So kind of going along with this is the ionic radius. Remember, an ion is just an atom with a charge, a positive, or I'm just abbreviating, so positive or negative charge. So now instead of just talking about the atoms, we're talking about atoms with positive or negative charges. Okay. So you can see in the pictures here, like lithium has a +1 charge, beryllium +2. And as you go down in the groups, remember all these are +1, +2, +3. Then there's a -2, -1, the noble gases, or next to the noble gases, sorry, the halogens. So when we talk about ionic radius, that's the radius of an ion. Um, If you look in different textbooks or on the internet, you might see actually different numbers, but really what we are looking at is the trend. So if you see different numbers in different areas, don't worry too much about that. What we want to notice is the trend. Are they getting bigger or littler? So when we talk about ions, we got positive or negative, right? Positive ions are smaller than the neutral. Same number of protons, but less electrons, right? So same number of protons pulling on less electrons. That positive charge means one less electron. Right? Negative ions, on the other hand, are larger than the neutral because they have added that extra electron, right? So they got more electrons, so they're bigger. More electrons, so they're bigger. Right? And when we talk about ionic radius, because as you go across, it goes positive and then negative. We don't worry too much about across. But as you go down a group, remember those groups are what have the similar properties. As you go down a group, the ionic radius increases just like the atomic radius. So that ionic radius increases, gets bigger, just like with the atomic radius, because we've added that extra layer. Right? There's an extra energy level, so that extra layer gives an increase in atomic radius. And we're going to skip that section here. All right, we have one more trend to talk about in the next video, and I will see you there.